Hello, this is your teacher David Garcia, and today we're going to learn how to write the standard form equation of an ellipse from the foci and the covertices. So as always, the first thing we have to do is determine whether we are dealing with a horizontal ellipse or a vertical ellipse. Now, we can do this just by looking at the information given to us in the foci. Why? Because on a horizontal ellipse, the foci will be around here, and on a vertical ellipse, the foci will be around here. So that means that on a horizontal ellipse, the foci will be sharing the same vertical coordinate, and on a vertical ellipse, they will be sharing the same horizontal coordinate. So in this case, if we look at the foci, we see that the coordinate that is changing is a horizontal one, and the coordinate that remains identical is the vertical. That means that we are dealing with a horizontal ellipse. So from here, we can let's get rid of this and this one here. We can start getting information. First of all, we know that the foci is as h plus c, comma k. This is one focus. We know this from the formulas. And the other focus will look like this. So if you pay attention, we already have the value of h, we have the value of c, and we have the value of k. So h equals 8, k equals 4, and now we're just missing the values for a, b, and we already have c, which is 3, the square root of 3. Now, in our ellipse, all right, let's say the center is around here. We know that the distance from the center to one of the vertices will be a. Now the problem here is that we don't have the vertices. All right, we don't know the location of this. But what we do have are the co-vertices. So that means that we have this point right here and this point down here. And B, in this case this one, will be the vertical distance from the center to one of the co-vertices. And B can also be understood as the change in y, or the change in the vertical coordinates. Now if we look at the points, the co-vertices, we have 8,7 and 8,1, all right, that are these 2 points in here. It only stands to reason that this point above is 8,7 with a greater value for the vertical coordinate, and this is 8,1. And we also have the coordinates for the center. Okay, we know that the vertical coordinate for the center, which is k, is 4. So the change in y will be 7 minus 4. That leaves us with b equals 3. There we go. Now, as we don't have the vertex, we will have to get a from the relationship of a, b, and c. On a horizontal ellipse, we know that c equals the square root of a squared minus b squared. We square both sides. So we have that c squared equals a squared minus b squared. All right, now we're going to isolate and change sides. So we're going to have a squared equals c squared plus b squared. And then finally, the square root on both sides. So I have that a equals c squared plus b squared. So substitution, we know that c is 3 square root of 3 squared, and b was 3 squared. We put this in the calculator and we get that a equals 6. So now we have all the information required to have the equation of the ellipse. So it's just a matter of substituting. So we have x minus 8 squared divided by 6 squared, which is 36, plus y minus k, that is 4 squared, divided by b, that is 3 squared, this is 9, and this equals 1. And this is the answer that we are looking for. And that's it. Thank you very much, and I'll see you in our next class.